start with one lesson of class 12, and this easiest topic I've chosen is matrices. I will be going about the NCERT book which has been prescribed by the CBSE. So let's get started. The topic is matrices. So first of all, we need to know what exactly is a matrix. So let us take an example. Suppose we have two people, A and B, and these people go to the shopping center to buy registers and pens. Suppose person A buys 5 registers and 6 pens, and this person buys 4 registers and 7 pens. Then this information can be put, the numerical information can be put within square brackets in this way. So this format of expressing the information is known as a matrix, and a matrix is always represented by capital letters. Let's call it matrix M. This matrix M has got the first row with elements 1, 5 and 6, the second row with elements 4 and 7, the first column going vertically down with elements 5 and 4, and the next column with elements 6 and 7. So here this matrix has got 2 rows and 2 columns. So the number of rows is usually represented by the letter M, and the number of columns in any matrix is usually represented by the number small, by the element small n. So here we can also define the order of the matrix M, which is written this way and is read as M by N. The matrix here has got 2 rows, 2 columns, so the order of the matrix is 2 by 2. The first row gives us a unique information. It tells us how many registers and how many pens have been bought by person A. Likewise, the first column gives us again a unique information, that is number of registers bought by person A and that by person B. So interchanging any of these numbers will interchange the information. So the information has to be this way only, written in rows and columns and in the right order. Since order of matrix is given by 2 by 2, so if you find out the product, you see that this number is equal to 4, which also gives us here the number of elements in the matrix. The matrix has got 2 rows and 2 columns, so the number of elements in the matrix is 4. So in a very generalized form, matrix A is represented usually this way. So we say this is a matrix of order M by N. The elements of the matrix are represented by small a, where I gives us the order of the row and j gives us the column number of the element, like this matrix here. So if I write down this matrix M here again, the element which is present in the first row and first column is 5. The element in the first row and second column is 6. The element in second row, first column is 4. And likewise the element in the second row and second column is 7. So far what we know is what exactly is a matrix, what is the order of the matrix, how many elements are there in the matrix, and which element is represented by which symbol. Now in this example only, looking at these elements, we get to know that there are 2 elements which have the same row number as the column number. So these 2 elements are basically the elements of the diagonal of the matrix. So this forms the diagonal of the matrix. The other 2 elements can be called as the non-diagonal elements. So what is special about elements of a diagonal? The row number would be equal to the column number. For non-diagonal elements, you can see the row number and the column number are different. So next, kinds of matrices. So the first matrix that we'll discuss is the row matrix. This is a special matrix. Let us represent it by A. A matrix which has only one row. For example, this. Because there is only one row, there are 3 columns, so the order of the matrix is 1 by 3. Next is a column matrix. As the name suggests, this is a matrix which has exactly one column. There is one column and there are 4 rows here, so the order of the matrix is 4 by 1. In this case, the number of columns can vary. In this case, the number of rows can vary, but here it has to be one row only and here it has to be one column only. A zero matrix, which is also called a null matrix. This is a matrix which is represented by the English letter O. So if a matrix has only one element, that element has to be 0. A zero matrix can have more than one elements and each of these elements is 0. We can also have a matrix of this kind. There are 4 elements, all the elements are 0. So this is a 0 or a null matrix. Then next we move on to a square matrix. This matrix is suppose represented by the letter C. A square matrix basically means the number of rows and the number of columns should be the same. So there is one row and one column. It is a square matrix. Now here it is not necessary it has to be 0. It can be any other real number this way also. There can be another square matrix with say 2 rows and 2 columns. This way. A matrix which has got 3 rows and 3 columns. So these are square matrices. These square matrices are very important matrices. We are going to study now, say, different kinds of square matrices. So, diagonal matrix. This is a square matrix, and a square matrix where in any square matrix there will be a diagonal. These are the elements of the diagonal, and the other elements are the non-diagonal elements. So in a diagonal matrix, suppose I am writing down 2 by 2 matrix, then the diagonal elements are non-zero elements. For example, this, and the off-diagonal elements, each is a 0. Because it has to be a square matrix, let's write down a 3 by 3 matrix. Once again, the diagonal elements are non-zero elements and the off-diagonal elements, each is a 0. This way. So you can see here that these are the diagonal elements and these diagonal elements are not 0. And they are all different real numbers. Scalar matrix. A scalar matrix is again another kind of a square matrix. Let's represent it by E. Once again, taking an example of a 2 by 2 square matrix. Here once again the diagonal elements are again non-zero and they are same, and the off diagonal elements are 0. A 3 by 3 matrix, the diagonal elements are again say -2, each diagonal element is -2, and the non-diagonal elements are equal to 0. So from here I think we can clearly see the difference between a square matrix, a diagonal matrix, and a scalar matrix. Okay, a square matrix, diagonal matrix, scalar matrices all have number of rows equal to number of columns. They all have diagonal elements. In a square matrix, the elements may or may not be 0. In a diagonal matrix, only the diagonal elements are non-zero numbers. The off-diagonal elements are all 0. The same thing happens in a scalar matrix. So what is basically different between a diagonal matrix and a scalar matrix? The basic difference lies between the diagonals. Here the diagonal elements are all same. They are not zeros, they are not ones. They are, except zeros and ones, there are some other real number which are equal. Here we have different real numbers. So that's the difference between them. Then we move on to the last kind of square matrix, which is known as the identity matrix. The identity matrix is also called a unit matrix, and we usually represent it by the capital letter I because it has to be a square matrix. So in a square matrix, the diagonal elements are equal to 1. Now because this is a 1 by 1 matrix, square matrix, so it has only diagonal element which is 1. In case it is a 2 by 2 matrix, then diagonal elements each equal to 1, the off diagonal elements are 0. If it is a 3 by 3 identity matrix, then the diagonal elements are again 1 and off diagonal elements are 0. So we usually have the idea of representing identity matrix as I1, I2, I3, which also indicates that this is identity matrix of order 1. Order 1 means it's a square matrix having 1 row, 1 column. Identity matrix of order 2, 2 rows and 2 columns, and likewise. So these are different kinds of matrices. The last concept of matrices that we are going to discuss is equality of matrices. If we compare two matrices, let us have a matrix A represented this way and another matrix B represented this way, then matrix A is equal to matrix B if the order of A is equal to order of B. So here we can note down that order of A is m by n, order of B is also m by n. In that case we can say that the orders are same, hence the two matrices are equal matrices. Let's take an example to again understand this in a little bit more detail. Let's take a matrix of order 1 by 3, another matrix of order 1 by 3. Because the orders are same, so we can say that the two matrices are equal, and if the two matrices are equal, the corresponding elements should also be equal. So the first element, which belongs to first row, first column in both the matrices, should be the same. Likewise, the element in the first row and second column in both the matrices is 2, which is also equal to y. Here this is also equal to x. So this way we are able to find out that x is 1, y is 2, and likewise z is equal to 3. So this is the basic concept of matrices. Now we'll move on. As I said earlier also, we'll be discussing only the NCERT context. So I'm going to take up the first exercise of matrices from the NCERT book. So we are starting here with the NCERT book exercise 3.4. 1. And let us start here with question number 2. According to this question, I'll read out the question first. If a matrix has 24 elements, what are the possible orders it can have, and what if it has 13 elements? So we are given here that the number of elements in a matrix is 24. Now we have to find out the order of the matrix. Now we know the order of the matrix is given by number of rows into number of columns, which has to be equal to the number of elements. So the number of rows can be 1 and the number of columns can be 24. The product gives us 24. The number of elements, it can be 2 and 12, 3 rows and 8 columns, 4 rows and 6 columns, 6 rows and 4 columns, and likewise we have these many options available for expressing a matrix which has got 24 elements. You can see here the product in each of these cases is 24. So this is how the order of the matrix, this particular matrix, can be defined in 8 different ways. If the number of elements in the matrix is 13, then that means the number of rows into number of columns should give us the total number of elements, which is 13. So if number of rows is 1, number of columns is 13, and vice versa. So there are 2 ways of expressing or writing down a matrix which has got 13 elements in it. It says find the values of x, y and z from the following equations. So 6th question has got 3 parts. I am doing the 3rd part here. The 3rd part says that there are 2 matrices which are equal, and these matrices have elements x plus y plus z, x plus z, y plus z, and this is equal to a matrix, Scalar matrix with elements 9, 5, 7. Equality of matrices. 2 matrices are equal. We can check that the order of this matrix, 3 rows, 1 column, 3 rows, 1 column, order is the same. So corresponding elements should be same. So we are getting x plus y plus z is 9, x plus z is 5, y plus z is 7. Let's say this is equation 1, 2 and 3. So we have to find out your values of x, y and z. Substitute the second equation in the first equation. So x plus z is 5. So 5 plus y is 9, which gives us y is equal to 4. Substitute the third equation in the first equation. So third equation gives us y plus z. So over here x plus y plus z, which is 7, equal to 9. This gives us x is equal to 2. So we have got here values of x and y. We have to find out z, so either substitute value in second equation or in third equation. So suppose we are putting value of x in the second equation, and according to second equation 2 plus z is 5, and hence z is equal to 3. So we have compared the 2 matrices, we have compared the corresponding elements, we get 3 linear equations, and solving these linear equations by the substitution method, we are able to find out values of x, y and z. Now question number 10. It's given in the form of an MCQ. The number of all possible matrices of order 3 by 3. Order of matrix is 3 by 3. So we know it's a square matrix, and each of these entries is 0 or 1. So each entry is either 0 or 1. So a 3 by 3 matrix, that means we'll have 9 elements. So I am just putting a dash here to represent this matrix. The first element can either be 0 or 1. The second element can be 0 or 1. The third element can be 0 or 1, and so on. So we start with this one. Now here we are using the concept of, say, combinations. The first element can have 0 or 1 arranged at this place in two ways. 0 or 1 can be arranged at this place in two ways. 0 or 1 here can be arranged in two ways. Likewise for each of these elements, and using the principle of multiplication, we are multiplying 2 9 times because there are 9 elements in this matrix. So the number of matrices would be equal to 2 power 9, which is equal to 512. If we change the question and we decide that there are elements, each entry can be either 0 or 1 or 2. So in that case, the first element can be either 0, 1 or 2. So these 0, 1 or 2 can be arranged at this place in three ways. 0, 1 or 2 can be arranged at this place in three ways. 0, 1, 2 arranged at this place in three ways. Likewise for all other places, we have 9 such elements, and the number of matrices in that case would be 3 to the power 9. So with this we end this lecture.